નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Good morning, students. Today we are going to learn Standard 10th Mathematics, Chapter 14, Statistics. So let's start exercise. Good morning, students. We have discussed mode and mean of the data. Now today we are going to talk about median. So first of all, let us discuss what is median, what is mode, and what is mean. Last time we have discussed difference or the meaning of the mode and mean. Now median is a measure of central tendency. Actually mean, mode and median, these are the three measures of central tendency. But it is such a measure of central tendency which gives the value of the middlemost observation in the data. Median is that gives the value of the middlemost observation in the data. Whatever the data is given, in that middlemost observation, the value of the middlemost observation, that is called median. Whereas the mode, what is mode? Mode is the most observation of the data. In a given data, what is the most observation? That is called mode. The observation with maximum value. Then mean. Mean is the average of the data. So mode and mean we have discussed, and here median. So you must know the difference between mean, mode and median. These are the three measures of central tendency. Now we are going to talk about how to find median for ungrouped data. So now for finding median for ungrouped data, we first arrange the data values of the observation in ascending order. First of all, we have to arrange the data value in ascending order for median. Is it clear? To find median, we have to arrange the data value in ascending order. First thing we have to do that. After that, if the number of observations is odd, n means number of observations. So if it is odd, number of observations here n, that is odd, then the median can be calculated using median is equal to n plus 1 whole divided by 2th observation. So suppose here n is 5, n is 5, that is odd. Then 5 plus 1 divided by 2, that is 6 by 2, that is third observation. So third observation, so here n plus 1 by 2th observation is the median. But if n is even number of observations, here even number of observations are there. So if there are even number of observations, then the median will be the average of n by 2th observation and the next to that is successive, that is n by 2 plus 1th observation. So that is median is n by 2th observation and the successive observation, that is n by 2 plus 1th observation whole divided by 2. So we have to take the average of n by 2th observation and its successive observation. So then we can get the median. So this is regarding how to find the median of ungrouped data. Now for this median of ungrouped data, we will take the example after this. First of all, let us go for how to find the median of grouped data. So to find the median of grouped data, first of all we have to go for cumulative frequency. So now for grouped data we use cumulative frequency. So what is cumulative frequency? What is the cumulative frequency? So here the cumulative frequency means what? First of all, after that we have to find out the cumulative frequency. So actually cumulative frequency is the frequency, cumulative frequency is the frequency obtained by adding the frequency of the class with its previous classes. That is called cumulative frequency. By adding the frequency of all the classes preceding to the given class, then it is called cumulative frequency. So suppose any frequency, we will take the example, you will come to know whatever the frequency is there for a particular class, we have to add all the frequencies of all the classes preceding to that, previous to that. That is called cumulative frequency. So first of all, we have to prepare the cumulative frequency distribution table. The class whose cumulative frequency is greater than or nearest to n by 2, that is called the median class. So after preparing the cumulative frequency distribution table, we have to find out which class out of the given classes, which one is the median class. So the class whose cumulative frequency is greater than, the class whose cumulative frequency is greater than or nearest to n by 2. Either the cumulative frequency of that class is greater than n by 2 or it is near to 1 by 2. Then it is called median class. So we have to find out the median class. We have to find out n by 2 first. Then we will come to know. Then the cumulative frequency we have to see which is greater than n by 2 or nearest to n by 2. The class of that is called median class. So after finding the median class, we can proceed for median using formula. So there is median is equal to L plus in bracket n by 2 minus CF divided by F multiplied by H. So what is this L? So L is the lower limit of the median class. Whatever the median class will calculate, in the out of that the median class will get, then the lower limit of that median class is called L. Then N, what is N? Number of observations. So we'll come to know n by 2, number of observations by 2. Then CF, that is called cumulative frequency. Cumulative frequency of the class. Which class? Preceding to the median class. The cumulative frequency of which class? Preceding to median class. That is called CF. And F, that is the frequency. But frequency of which class? That is the frequency of the median class. So we have to take the cumulative frequency of the class previous to the median class, and frequency we have to take the frequency of the median class only. And H, that is called class size. So this, using this formula, we can find out median of grouped data. So first of all, we will go for example of ungrouped data using this formula, where we will see n is number of observations, odd or even. Then we will learn how to prepare cumulative frequency distribution table. There are two types of cumulative frequency distribution table. That is, one less than type cumulative frequency distribution table and more than type cumulative frequency distribution table. Then using that table, we will find how to find the median. So we will take the example. So now example. Good morning, students. As we have discussed earlier regarding mean, mode and median. Here the mean means we have discussed average of the data. Then we have discussed mode, the most occurring observation, value of the observation is called mode. Now median means the 50% of the observation value less than that and 50% of the observation value greater than that. Now today let us discuss how to find median of ungrouped data and then for grouped data by taking example. So first of all, let us find median of the ungrouped data. Here one data is given, marks out of 50 obtained by 100 students. Here marks of 100 students given, obtained out of 50. But data will be given here, marks obtained 20, 33, 42, 25 randomly, and number of students, here 6 students having scored 20 marks, 28 students having scored 29 marks, 4 students having scored 38 marks. Random data will be given. So first of all, we have to prepare the frequency distribution table. So for that we have to arrange marks in ascending order. So I have already arranged marks in ascending order, 20, 25, 28, 29, 33, 38, 42 and 43. Then we have to write the corresponding frequency. That means the number of students having scored 20 marks, 25 marks, 28 marks and so on. Is it clear? So now prepare the cumulative frequency distribution table. So after arranging them in ascending order, we have to go for cumulative frequency distribution. So for cumulative frequency distribution, what we have to do? Here, what is cumulative frequency? That means here marks obtained by the students 20 marks or less than that. So here up to 20 marks, up to 20. Up to 20, how many students are there? There are 6 students having scored marks up to 20. Then we have to go for up to 25. Up to 25 means 25 or less than that. So there are 20 students having scored 25 marks and there are 6 students having scored less than that. So we have to add these two. 6 plus 20. We will get here 26. Now there are 26 students having scored marks less than up to 25. Now up to 28. That means those have scored marks 28 or less than that. So there are already 26 students having scored marks less than that. Now there are 24 more students having scored 28 marks. So 24 plus 20, 26 plus 24, that is 50. So cumulative frequency of this class is 50. Then students having scored marks up to 29. That means already 50 students are there having scored marks, this total sum. So that means all the students having scored marks 29 or less than that. So already 50 are there, this total plus 28, that is 78. Similarly, up to 33 plus 15, so we will get 80, 93. Then up to 38, 4 more students, so 97. Then up to 42 marks, 2 more students, 99, and then up to 43, highest 43, so up to 43, all the 100. So total number of students will come at last, because all the students have scored either marks 43 or less than that. Nobody has scored more than 43 marks, and therefore total number of students here will get at last. Is it clear? Now we have to find median. Okay, so for that, first of all we must know n. N means number of students. So number of students 100, and n is even, that is 100 is even. If it is odd, we know how to find median for such discrete ungrouped data, that is n is equal to odd number, then we can add 1, n plus 1 divided by 2. So you will get the middle here, you will get the middlemost observation. Barabar? But here now we want to find out for n is even, and therefore the median is denoted by m. So we can say n by 2th observation plus n by 2 plus 1th observation. That means we have to take, there will be 2 middlemost observations, and so we have to take average of these 2 middlemost observations. Is it clear? So first of all, therefore here median is equal to n by 2th observation, that is 100 by 2, that is directly we can say 50th observation, plus here next to that plus 1. Here 50th observation, so here 50 plus 1, that is 51st observation. So these are the 2 middlemost observations out of 100. You see, in 100, middlemost is 50 and 51st. Here we cannot have one middlemost. If n is odd, then we can have only one middlemost observation. That is n plus 1 divided by 2, you will get exactly middlemost observation. But here there are 2 middlemost observations, so we have to take average. And therefore, here we will get, therefore median is equal to 50th observation now. So which one is the 50th observation you see? Here exactly the 50th rank, the student, there are 50 students having scored marks 28 or less than that. So there are up to 26 students marks up to 25, but 27th student onwards up to 50th student all the students have scored 28 marks. So 50th student has scored 28 marks. And then next to that 51st student has scored here 28, next 51 to 78. So 29 marks scored by 51st student. And so the average of this is equal to, here we will get 57 by 2, and that is, we say here median is equal to 28.5. So 28.5 is a median. That means that there are 50% of the students have scored marks less than 28.5 and 50% have scored marks more than 28.5. So that is what here median of ungrouped discrete data. Now we have to obtain the median of grouped data. This we have studied last year also, but now this year grouped data, median of grouped data. So to find the median of grouped data, we have to make use of cumulative frequency distribution. We have to make use of cumulative frequency distribution, less than type and more than type, because here we are dealing with grouped data, classes are there. So we have to go for two types of cumulative frequency distribution, less than type cumulative frequency distribution and more than type cumulative frequency distribution. But here first of all we will discuss how to prepare the table of less than type cumulative frequency distribution, and then using this only we can find out median using formula. Whereas how to find more than type cumulative frequency distribution we will discuss later, and that will help us to draw graph, that is OGIM. Okay, now here data is given, marks obtained by some of the students here out of 100 in a test. These marks 0 to 10 marks are scored by 5 students, 10 to 20 marks scored by 3 students, and so on given. Now here class with equal class length is given. We can also find with unequal class length, but here we are going to discuss only for equal class length. For this you see here lower boundary point and upper boundary point. These are the classes with boundary points. So this is lower boundary point and upper boundary point. That means that the students having scored marks 0, equal to 0 or more than that, but less than 10. There are 5 students having scored marks less than 10. Here 20 or less than 20, but here now 10 or less than 10 not, but we have to consider 0 equal to 0 but less than upper boundary point. So here 10 marks or less than, greater than that but less than 20, like that here given. So first of all we will go for less than upper boundary point. So less than, we say less than 10, less than 20, less than 30. No need to put sign of less than, you can write upper boundary point. Here it is written less than upper boundary point. Less than 40, less than 50, less than 60, less than 70, less than 80, less than 90, and less than 100. How many students are there having less than 100? All equal to n. Let us see how many are there. So first of all, prepare the cumulative frequency distribution of less than type. So how many students are there having scored marks less than 10? So there are 5 students. Then having scored less than 20, how many are there? These 5 students are already there. But also more than 10 or more than 10, there are 3 more students. So we have to add 5 plus 3, that is 8. Similarly less than 30, so 8 plus 4. Now you see this total already scored marks less than 20, how many are there? Less than 20, there are 8 students. So now scored marks less than 30. This 8 plus 4, this that is the students that is previously added. That is 8 plus 4, 12. Similarly, less than 3. Here less than 40. There are 3 plus. So we will get 15. Then plus 3, 18. Then 18 plus 4, 22. Then 22 plus 7, 29. Then 29 plus 9, 38, and then 38 plus 7, 45, and then 45 plus 8, 53. So here n is equal to 53. So here n is equal to 53, and therefore n by 2 is equal to 53 by 2, and that is equal to, here we will get 26.5. 26.5, that is n by 2. Is it clear? So here we need n and n by 2. Now we will go for median class. Here, as we have done in model class, same way here model class means highest frequency, the class having highest frequency, model class. But here now median class is not in that way. So for median class we have to depend on n by 2. Now n by 2, that is 26.5. So 26.5, which lies in which class? You just see 26th, actually 26.5, we cannot have the rank like that. Either we will get 26th student or 27th student. Okay, but here we have to consider n by 2 and decimal 26. So there are already 22 students here having scored marks up to 60. Is it clear? Up to 60, less than 60 there are 22. Then 23rd student onwards, remaining 7 students, 23rd to 29, that is 23rd, 22, then plus 7, that is 23rd to 29, there are students. So 26.5 comes in this range after 22nd and before 30, that is in this. So the students having score here, that is 26.5, that cumulative frequency lies in this class, and this is called median class. So median class is 60 to 70, and so L, what is L? That is lower limit. Lower limit is 60. Okay, so here we got n is equal to 53. That means n by 2 is equal to, we got 26.5, and then we got median class. So here median class we got 60 to 70, and therefore here L is equal to 60, that is lower boundary point or lower limit we say. But here now one more thing we need, that is H, class width. So what is class width? Class width you can see here 10 and 20, difference is 10. So here difference between two consecutive upper boundary points or lower boundary points, it is class length or class width. Okay, so these are the things we need for calculation. Also we have to go for cumulative frequency. What is the cumulative frequency? CF, and also we want F frequency. These are the things required here. So what is this cumulative frequency? Can you tell me? Cumulative frequency, we have to take the cumulative frequency of the CF, means cumulative frequency of the class previous to median class. So median class is this. So we have to take the cumulative frequency of the class previous to median class. Previous to median class, and that is 22. You can say this is 22. Cumulative frequency 22. And frequency of the class. Frequency of the class, okay, which one? Median class, and that is 7. So frequency of the median class itself we have to take, that is 7, but cumulative frequency we have to take of the previous class, and that is 22. So using this data, let us find out median of this. To find median, there is a formula for continuous frequency distribution with equal class length in grouped data. So we have to use formula, another formula that we have used on grouped data. That formula will not work out here. So we have to use the formula, and that is, therefore median is denoted by M, and that is equal to L plus, here we have to go for the median, that is L plus, what we can take here is CF minus N by 2 minus CF. Okay, median class is equal to lower limit plus N by 2, that is, we have discussed N by 2 here, N by 2 minus cumulative frequency divided by frequency multiplied by class width. So this is the formula. Therefore, median of this data here, we have already calculated L, that is lower limit 60 plus n by 2. So n by 2, that is n equal to 53. So n by 2, that is 26.5 minus cumulative frequency of the class previous to median class, that is 22, divided by frequency of the same class, median class, that is 7, multiplied by here width, class width is 10. So therefore we will get median is equal to 60 plus 26.5 minus 22, that is 4.5 divided by 7 multiplied by 10, and therefore median is equal to 60 plus, here you will get 45 by 7. So convert it into decimal. Here we will get 60 plus, we have to convert 45 divided by 7, and so we will get here 6 point, then 6 for the, then we will get 6, 7 ja 42, 3 left 30, so 6.428, we will get 6.428 and so on. So we can take approximately, we can take it is 6.43, and therefore the median is 66.43. So approximately we can round off up to 2 decimal places. So this is the median of this data. So here that means that there are 50% of the students are there having scored marks 66.43, less than 66.43. Your median class will lie always in this median class. Median will lie always in this median class. So your students having scored marks 66.43, that means students having scored marks less than this are 50%, and 50% of the students have scored marks more than this in this median class. Okay, so next time we will discuss how to prepare the more than type cumulative frequency distribution table, and after that we will take the illustrations based on median using grouped data.
Thank you for joining us.